Globbing is a weird word, but in the context of ZSH, globbing means what happens when tab completion and the find command make beautiful music together. Let's jump right in. If I have a command that I want to execute on every file within a particular directory, I can use star. And this is pretty much the same as regular expressions. It's the same as you could use with find. So if I say echo star, that will echo every file in the current directory. And you can see with ls that this is the same as every file in the current directory. If you want to get a little bit more complicated, let's say that I only want the text files. So then I could say echo star.text. And what it would do is it'll actually use the star to complete everything that can match that pattern. If I actually want to use tab completion, I can. If I say echo star.text and then instead of hitting enter I hit tab, it will complete that into everything that it can possibly expand to. And you can always use this in Z Shell when you want to see what a globbing pattern would expand to. In regular expressions, you know that you can also specify a individual range, and you can do the same thing with ZSH. You just have to use the range characters brackets. So let's say that in this directory I have a C file and an H file, and I want to echo both of those. In that case, I can just say echo resume.ch. And you can see that it echoed both resume.c and resume.h. You can also use a question mark if instead of doing CRH I wanted to do anything that ended with a one-letter extension, because the question mark character can mean anything that is one character. If you want to do anything that involves a regular expression, Z Shell globbing has a pretty complete regular expression engine, so if you've already gone through the regular expression and grep module, then you can just have a complete ballpark here. But there's even more that you can do. You can also qualify your expressions, and you can do a recursive directory lookup. Let's go there now. So you can see here in this directory I have a recurse directory. And in a general situation, I might have a really big directory tree and I want to print out everything in any directory tree that matches a given pattern. In order to do a recursive directory lookup in Z Shell, all you have to do is *****. If I say echo *****, the *** says every subdirectory of the current directory. The star says every file in that directory. So you can see it echoed recurse, recurse/Firefox, recurse/Ninjas, and all of the stuff inside the recurse directory, in addition to everything inside the current directory. This is very useful if you want to print out anything that is in any subdirectory of the current directory. For me, this has almost completely replaced the find command, because I can always just use **** to say I am looking for any file that is in the subdirectory of the current directory. This is very commonly used with grep, so if I want to grep for the string this in any file that is in any subdirectory of the current directory, then you can see that it comes up with the notes file inside recurse that says this file is not empty. Whenever you want to just find if something is anywhere, you can do something like grep pattern any subdirectory of the current directory. Let's say that I don't just want any subdirectory of the current directory, and I don't want just any file in there, but I actually want to combine it with the regular expression patterns that I did before. That's perfectly fine. So instead of saying ****/*, I'll say ***/ some given kind of file. So ***/*.text. And that will print out every text file in any subdirectory of the current directory. That's good if I know the particular file that I want, but what if I only want a particular type of file? And that's where qualifiers come in. Whenever you want to do a qualifier, you follow generally the same syntax, but then you put a parentheses after it. And whatever goes inside the parentheses are the qualifiers. If you put a not that if you put a caret, then that is a not. In other words, that will mean it will negate all of the qualifiers following it. If you put a hyphen, then that will mean it will follow all symbolic links. And this is probably a bad idea if you have any circular symbolic links, because that can mean that you can get basically into an infinite loop. So for the meantime, we're just going to ignore these two commands. There's something that you can use easily, and they'll work just pretty much as expected. One of the qualifiers that you can do is a type qualifier. Let's say that I only want the executable files. Then inside the parentheses, I put a star. You can see the two things that it prints out are recurse/firefox and recurse/script.py, both of which are marked as executable files. And you can see if I change into the recurse directory and I ls-al, these are green, meaning they have execute permissions. So if I have a star inside the parentheses, that's an executable. If I have a dot inside the parentheses, that means it's a regular file. So pretty much everything in here will count as a regular file. The exception is the directories and symbolic links. If instead of a regular file, I want a directory, then you use the slash. So you can remember slash because it's the same slash that you would use to separate directories from subdirectories or from files. If I want symbolic links, then you use the @ command. And I actually didn't put any symbolic links in the any subdirectory of the current directory. But if I made a symbolic link just to recurse, you can see inside here I have this symbolic link. And now if I echo **** then it will print out recurse2. That's all well and good if we only care about the file type, but what if we also care about the file permissions? For that, we can use permission specifiers similar to what we would use in chmod. RWX is saying that the owner can read, write, and execute. AIE is saying the group can read, write, and execute. I have no idea why it is AI or E. And capital RWX is files that the world can read, write, and execute. So here you can see Firefox is the only thing that matched because here no other file had all of those permissions set on it. And if we ls***-al, you can see not in the current directory and not in a subdirectory. This is the only thing that was world readable, writable, executable. If we search for all files that are owner, readable, and writable, then we come up with a lot of them. Because, as you can see, everything here is owner, readable, and writable. If we search for any files that are owner executable, then this will not get files that are only readable and writable. It will only get files that are executable. And you can see recurse, recurse2, Firefox, and script.py. So recurse and recurse2, you can see are directories, and those directories are actually executable because of the way that permissions work on Unix systems. But normal executable files are script and Firefox, and both of those are owner executable. And to clarify, you can combine these pretty much at will. So if I do something like RIEX, then that will say files that the owner can read, files that the group can write and execute, and files that the world can execute. And only if something matches all of these permission qualifiers will the file be printed out. So you can see, again, Firefox is the only one that had all of those permission qualifiers. You will notice, however, that Firefox didn't just have these permission qualifiers. Firefox also had plenty of others. What that means is that the things that we don't specify here could be any value. It can be either owner readable, owner executable, or not owner executable. It can be owner writable or not owner writable. It can be group readable or not group readable. None of these things matter because we didn't specify them. If we want something to not just be unspecified, then we have to use the not command that I talked about at the very beginning. So for instance, if I say echo ****, something that is user executable and not world executable, then this will not match Firefox, because Firefox is world executable. And you can see it matches the directory, because the directory is not world executable, but it is owner executable. And it also matches script.py, which is only executable by the owner. Another type of qualifier is time qualifiers. What these do is they let you check what was the file accessed, modified, or what time the file inode was modified. And if you don't know what an inode is, then that is beyond the scope of this course. And in order to do this, you say, still again, inside the parentheses, you say either A, M, or C for access, modify, or inode modify. So let's say last time it was the file was modified, so M. Then you specify what the units are on your time. So if you do a capital M, that is for months. If you do a W, that's for weeks. If you do an H, that is for hours. If you do a lowercase m, that is for minutes. And if you leave it completely out, then it is days. Then you do a plus or minus. Minus means within the last n days. Plus means more than n days. So for instance, if I say mm minus 5, then that will give me all files that were modified within the last 5 months. And you can see all of these files were modified within the last 5 months. Since these are the modify times, you can see that there are some files that were modified February 23rd and some that were modified December 7th. So if I do something like within the last 1 month, then it will only get the February 23rd ones and it will not get the December 7th ones. Let's try that. You can see that doesn't have summer resume, doesn't have updated resume. It only has the ones that were more recently created and modified. If we change the minus to a plus, then that gives us exactly the opposite, because it will say not within the last 1 month, but more than 1 month ago. In other words, any file that did not match this one will match this one, because all of these files were last modified greater than 1 month ago. If instead we want to do it in hours or minutes, we would just change the capital M to lowercase m for minutes, and every file in here was modified greater than 1 minute ago. You've been listening to me blab on for longer than a minute. If you do greater than 1 hour, you can see it's pretty much the same as greater than 1 month, because all of these files that were executed on February 23rd were pretty much executed right now, or pretty much modified right now. And you can do pretty much whatever you want in terms of the times with this. Generally, I find modified to be the most useful, but if you do want to deal with access, then you can say accessed greater than 1 hour ago, or accessed greater than 1 day ago, or accessed greater than 1 month ago, or accessed less than 3 months ago. And you can also combine these with the modifications with the other qualifiers. So permission qualifiers, directory type qualifiers, or file type qualifiers. So for instance, if I want something that is a executable file that was modified greater than 1 day ago, then I use the star for an executable file, M for modified, and +1 for greater than 1 day. You can see Firefox matches this one. What if I want all executable files that were modified less than a day ago? I would say the -1, and it would give me script.py. What about all directories that were modified less than a day ago? What about all regular files, so all files that are not directories, that were modified less than 1 day ago? Combining these is where the power really comes from, because that means you can specify exactly what type of file you want to find. And if you know I edited some file a little bit ago, then you can just exclude from your search every file that was executed months and months ago. The last qualifier that I'm going to talk about is size qualifiers. To specify a size qualifier, it's the same as all of the other ones in that you have to put it inside parentheses, and it starts with L. L stands for file length, and it is, in fact, a capital L. If you want to specify kilobytes, you then say K. If you want to specify megabytes, you say M. And if you don't specify anything, then that's just bytes. The plus and minus will work similar to time qualifiers. Plus means bigger than n, minus means smaller than n. And then you give n, in other words, the number of bytes, kilobytes, or megabytes. So if I want files that are greater than 5 bytes, then you can see only the directories and symbolic link and notes.txt are greater than 5 bytes. All of the other ones, in fact, are completely empty. And you can see that when I ls-al. The directories all are moderately big because it takes some space to store a directory entry. All of these files are 0 because if I open one of them up, you can see, in fact, these were just dummy files that don't really have anything in them. You can, again, combine size qualifiers with time qualifiers and with the directory type qualifiers. So for instance, if I want an executable file with length that is less than 5, this will return all executables that are less than 5k. In other words, all of the executables. If I want a regular file that is greater than 5 meg, this won't return anything because there are no regular files that are greater than 5 meg. If I want a directory whose length is greater than 1k, you can see recurse is greater than 1k because it is a directory. Directories are 2k. If instead I want to say all regular files whose length is greater than 1 byte and that are readable, writable, and not executable, then that will, again, match notes.txt, which is, coincidentally, the only file whose length is greater than 1 byte, but also it is a regular file, and it is readable and writable and not executable. And so if I said readable, writable, executable, then there would be no matches found because notes.txt was the only one that matched all of that, and it was not executable. To review, when we're globbing in ZSH, we can do pretty much everything that find can. What that means is that we can do stuff within a given directory, such as use star to find all the files, use bracket notation to specify a range. We can use a question mark to specify an individual character, and we can use other regular expressions. This gets even more powerful when you do recursive directory lookup. So if we say star star, that will match every subdirectory of the current directory. If we say star star slash star, then that will say every file in every subdirectory of the current directory. And we can really get a lot of weight out of that when we put some qualifiers inside here. And those just go in parentheses after the end of the pattern that you want to match. For any qualifier, you can use the not key, which will negate everything after that, which means that you can have stuff before it. So if you have star not dot, then that will say every directory, or every executable file that is not a regular file. There are type qualifiers, including star for executables, that is a very horrible star, dot for regular files, slash for directories, and @ for symbolic links. There are permission qualifiers, which are RWX for user read write execute, or for owner read write execute, capital AIE, for group read write execute, and capital RWX for world read write execute. There are time qualifiers, where you have to specify first either access modify or inode modify. Then you have to specify month, week, hour, minute, or omit it completely for days. Then you have to specify plus or minus, where minus means within the last n days and plus means more than n days. And then you specify n. In other words, you could say inside the parentheses m plus 3 to find any file that was modified more than 3 minutes ago. The last type of qualifier we talked about was size, and size works pretty much like time. To do the size, you just have to specify L for length. Then you have to say whether it's kilobytes, megabytes, or omit that field to just do bytes. Then you say plus or minus, which works pretty much the same way as the time. So plus means bigger than, and minus means smaller than. And then you say n for exactly how many bytes or kilobytes or megabytes it is bigger or smaller than. This all gets really powerful when you can combine the size, the type, the permissions, the time, and all of this can be done recursively or just in a given file place. And all of it can be done with pretty much any command because it's done on the shell level. In other words, ZSH will do all of this for you. And to clarify, all of these features are available in Z Shell and are not available in very many other shells. So this is pretty much the reason why I use Z Shell. If you want a further reference on this, there's an article on Tux Radar called Z Shell Made Easy that I read through when I was making this lecture. So the lecture notes on this will match very closely with the guide there. And also, if you want a much more dense and verbose guide on all of this, then you can look at Z Shell's man page, and you can see all of these commands in more depth.